In this lesson, we're going to be adding and subtracting rational expressions. You can use the same rules to add and subtract rational expressions that you use to add and subtract numerical fractions. You can add the numerators of rational expressions that have like denominators. So, for example, if we're asked to add the rational expression 2 over 5a plus 1 over 5a, because they have like denominators, we can add the numerators. 2 plus 1 is 3, and we keep that like denominator, 5a. And so our sum is 3 over 5a. Likewise, with the sum 7p over x plus 4 added to 3p over x plus 4, we have like denominators, and so we can go ahead and add numerators. 7p plus 3p, those are like terms, so we end up with 10p, and we keep the like denominator, x plus 4. And so that is our simplest answer. And we can now move on to looking at an example of a difference. In this example, 3x over the trinomial 5x squared plus 9x minus 2, and we're subtracting the entire quantity, negative 2x plus 1 over 5x squared plus 9x minus 2. We have the exact same denominator, so we don't need to worry about creating like denominators. But what we want to do is we want to focus on that numerator. I put a parenthesis around it so that you can see we're subtracting the entire rational expression. So if we're subtracting, it's as if we are adding the opposite of each one of those terms. So if we're going to focus on the numerator, we have 3x's plus now 2x's minus a 1. We do have some like terms here. 3x's plus 2x's is 5x, and then minus the 1, the constant. So our numerator, we can go ahead and rewrite it now as 5x minus 1 all over our common denominator was 5x squared plus 9x minus 2. This is a quadratic that can be factored, however. So let's now look at the denominator and how we can factor that. It factors into, I've written this out for us, 5x squared plus 10x minus 1x minus 2. My factors of negative 10 that add up to 9x are positive 10x and a negative 1x. And so then that factors into 5x minus 1 times the quantity x plus 2. So we're going to go ahead and put our simplified or our factored denominator. And what we see now is the numerator that we found can cancel with our factor, one of the factors of our denominator. And so our simplest answer for that difference is 1 over x plus 2. Our next example involves a sum where we do not have common denominators. And so what we need to think about is finding the least common denominator. And so what we can do is we can look at the coefficients, the 9 and the 3. Our least common denominator of a 9 and a 3 would be 9. And our least common denominator of x and x squared, if we're looking at now at the variable portion, is an x squared. So we're going to go ahead and try to create a common denominator of 9. So our least common denominator is going to be 9x squared. That's because, once again, the least common denominator between 9 and 3 was 9, and our least common denominator of the variable, the x, is an x squared. So what do we need to do? Our question is, what do we need to do to get a 9x to turn into a 9x squared? Well, we would multiply by x. But if we're going to multiply the denominator by x, we have to multiply the numerator by x. So this is a funny form of 1, a foo, x over x. And so it creates our first rational expression in our sum is now going to turn into 2x over 9x squared. In order to turn 3x squared into a 9x squared, we have the x squared part, but we need to multiply by 3 to get the 9. If we multiply the denominator by 3, we need to multiply the numerator by 3. And so we have another foo, a funny form of 1, and that is going to be, now our new rational expression as part of our sum is going to be 3 over 9x squared. So now we have common denominator, 9x squared, and we have the 2x plus 3, and so those are not like terms, so we're going to have to go ahead and leave it as 2x plus 3 all over, keep the denominator, 9x squared. And there's no factoring that we can do with that, so this is our final answer for that particular sum. We have one more example. This one will be a difference, and it's a difference of the rational expression 4 over x plus 2 minus the rational expression 1 over x minus 3. This one, really there's no way to create a common denominator other than to multiply by a funny form of 1 that is the binomial from each of the opposite expressions in our difference. So we need to multiply 4 over x plus 2 by an x minus 3 over x minus 3. And we'll need to multiply 1 over x minus 3 by x plus 2 over x plus 2. And so we need to remember how to work FOIL. Our denominator now becomes x minus 3 over x plus 2. I'm going to hold off on performing FOIL for just a minute because we may end up having something that is able to cancel. And so less work, less chances of error. So let's hold off on FOIL for just a minute. Up in the numerator, we have 4 times the quantity x minus 3, and then we're going to subtract. This is a place where we need to really be careful. We're subtracting an entire product here. We're subtracting 1 times x plus 2. So we're subtracting the entire x plus 2. So that's like distributing this negative sign. So what does that look like? It looks like in the numerator 4 times x minus 3 minus x minus 2, and we should go ahead and distribute this 4. So that's a 4x minus 12 minus an x minus a 2. Well, we have some like terms to gather up, my x's and then my constants. So I have 4x's minus 1x, and I have a negative 12 minus 2 more. So my numerator, here we're focusing on the numerator right now, four x's minus 1x is 3x. Negative 12 minus 2 more is a negative 14. So my numerator is 3x minus 14. My denominator was the x plus 2 times x minus 3. And there are no factors that we could simplify, so we can go ahead and do FOIL. We have 3x minus 14 all over. First is x squared. Outer would be a negative 3x. Inner would be a 2x. And last would be a minus 6. So this then becomes 3x minus 14. I'm going to gather up these like terms all over x squared minus x minus 6. And that's my simplest answer for the difference.